Here we are at example 2b from our 4.3.4.4 set of notes. We're asked to factor the following, and in just looking at this, we notice that we have 25g squared minus h squared. We actually only have a binomial here, so again, that's just two terms, and we're asked to factor this thing. Well, our first step is always just to see if we have that greatest common factor. Unfortunately, they don't. There's nothing in common between these two. So pretty much step one is out the door. Now we look at step two, and that is really just to kind of try and tear this thing apart if we can. Now at first glance it might look like we can't do a whole lot with it. However, let's just start out just to see if we can kind of create those two binomials right next to each other and just kind of see what happens with the numbers. So if we have 25g squared, you could do 1 times 25, or more likely we want to choose those numbers in the middle, like 5 and 5, to get the 25. Also, likewise for the g squared, we know that we have to have a g here and a g here, really to kind of get that g squared like we've seen in class. Now that's not always ironclad the case, but by and large for what we're learning it is. Now when we look at our h squared, we know that in order for the two things, the last two numbers, when they're multiplied together, we end up with an h squared. So as a result of that, we have to almost pretty much kind of like with the red one, we pretty much have to have h and h to get that h squared. Now again, that's not ironclad every time, but pretty much 98% of the time we're going to see that scenario. Now, looking at kind of the signs of this, well, notice how there is no middle term at all in between these two perfect squares. Really, this is a perfect square, this is another perfect square, and we're kind of taking the difference of those two perfect squares. If we kind of just go ahead and distribute, just to kind of confirm what we were seeing, we have 5 times 5, well, that again gives us the 25, and the g times the g gives us our g squared. So that pretty much just checks out for the first part. Then we end up with distributing this first 5g to the h and getting 5gh. Likewise, when we distribute now the h into the next set of the parentheses, we end up with another 5gh. And then lastly, when we distribute that h to the final h, we end up with h squared, completing kind of this last piece. We have that again, that h squared. Now this is again where things get a little trickier. When we're talking about the signs of these, notice how there's nothing in between this 25g squared or this h squared. There's really just this negative. And this negative pretty much goes with the h, okay? So we can kind of pretty much think of him as part of that h squared. And we've talked in class about how this is really the same thing as adding a negative, and so that's why it's part of the h squared. Really what's kind of giving us the issue is this part right here. This 5gh, another 5gh. But as long as we were able to make one of them positive and the other negative, then as a result, they'll pretty much just cancel out with one another. So kind of going back to our factored form, how could we get this 5gh right here to be positive 5gh? Well, if we look at 5g and we multiply it by a positive h, we should end up then with that positive 5gh. If on the other hand, when we multiply our h times the 5g, well, we really want it to be negative so that it'll cancel out with that previous positive 5gh. And as a result, this guy has to be negative. Okay, so this now is our factored form for what we were just looking at a moment ago. And again, the green at the bottom really just kind of helps illustrate and prove why that is. Now this really leads us to an interesting definition, and that is the difference of two perfect squares. So anytime you see a perfect square and another perfect square, and the key is that you are taking the difference of those two perfect squares, then it will always factor out into the form a plus b times a minus b. And what we're talking about is, well, what is a and what is b? imagine going back to our example where now that we have that definition, a plus b and a plus b times a minus b, oops, a minus b. The key really becomes, well, what are a and what are b? The a is essentially this 5g. And how do you get that? Well, it's pretty much just taking the square root of this first part. So really, a is just 5g. For the b value, it's pretty much the same thing what we just did a moment ago. Just take the square root of this, and then there's our b value. And now all we really need to do is just plug these in where they belong. Not much math is required. That is kind of the shortcut, but you're going to recognize these difference of squares. They pop up quite a bit. Okay. You could also think of it as, I've had students think of it as what, when we square it, gets us the 25g squared. And 5g would accomplish that. That would be considered the a. Or what squared gets us this h squared? Well, h would accomplish that. There is the a, and then there is the b. Again, though, that is 2b from our 4.3, 4.4 set of notes.